So definition of work. When a force is applied on a particle if we get a displacement or any displacement then we say that the force does work. So if a force is applied on a particle and if we get a displacement or any displacement of the particle, then we say that the force is does work. So what is the numerical representation? If we draw a line and if we take a object of mass m and if we applied a force F and if we get a displacement S, so this is the force F applied on this particle and we have obtained a displacement of this particle of S. Then we say that the work, the numerical form of the work is equal to force multiply displacement. So this will be force F multiply displacement is S. So this is the numerical form of the work, and if we take the work is applied with an angle theta, then the diagram will be changed. We are taking now the force is applied on the particle with an angle theta, and the displacement is in this direction. And again we are taking the displacement is S. So here are two components, a vertical component and a horizontal component. So we will take the horizontal component which is along the displacement f cos theta, and f sin theta will not take. Then we will get the numerical form of the work. So here work is the second case. The first case This is the second case. Work W is equal to F cos theta multiply S. So this can be written down F S cos theta. If we recall the definition of scalar product, then we can write down in vector form also. This will be F vector dot S vector. So these are the numerical form of work. Now work is considered a scalar quantity. It has magnitude but no direction. So work is scalar quantity. And its CGS unit is arc, and SI unit is joule. So we can very easily establish the relation between the joule and arc, the CGS unit and SI unit. So it will establish a relation between the joule and arc. So here we take 1 joule is equal to 1 Newton and 1 meter, multiply 1 meter, 1 Newton multiply 1 meter. So this is, we know that 1 Newton is equal to 10 to the power 5 times. And 1 meter is equal to 100 centimeter. So this will be 10 to the power 7 9 centimeter each. The CGS unit of work, this will be R. So this is the relation that 1 joule is equal to 10 to the power 7 R. Now if we consider the case 2, here if we take theta is equal to 90 degrees, then work will be, if theta is equal to 90 degrees, then work FW is equal to F S cos 90 degrees. So cos 90 degrees is equal to 0. So we will have the work is 0. So if the applied force, this vertical component and the displacement is at the angle 90 degrees, so this force will not do any work for this displacement. So this component will not do any work for this force. Vertical component of the force will not do any or will not perform any work for this displacement. So for such kind of force is called workless force. Now if we go to answer the power, definition of power. So rate of change of work is called power. Work is called is also a CGS quantity. It can be numerically represented in this way. Power P is equal to work done and the time taken to perform this work. So work can be written down in this way. Work is W and time is T. Now we have know that work is equal to force multiplied displacement by T. So if we consider this term, the rate of change of displacement is called velocity. So this will be force multiplied velocity. So this is another numerical form of power, that work multiplied velocity, force multiplied velocity is equal to power. Now the SI unit of power, is watt. So if any particle or any force actually does a work of 1 joule in every second, then its power is called watt. This is the definition of watt, that the rate of change of any objects perform work of 1 joule in every 1 second, and then its power is called watt. Now if we will go energy, definition of energy is that the ability to do a work which called the ability to do a work is called its energy of any object. So its units are same of work. The CGS unit is R and SI unit is Joule. And it is also a scalar quantity. It has magnitude but no direction. So it is also a scalar quantity. Now there are two types of mechanical energy. There are various types of energy. So one is mechanical energy. It is also two types. One is kinetic energy. potential energy. So we place kinetic energy and potential energy is numerical forms. Kinetic energy means if any particle is in motion, then its total energy is called kinetic energy. And if any particle changes its shapes, its position, then the total energy stored in it is called potential energy. So the numerical form of kinetic energy, how it can measure kinetic energy. So what is the work done for generating kinetic energy? We have to first find out. So this is, if we will take work, the work done to generate kinetic energy is equal to, we know that this is force multiplied displacement. So F multiply S, which can be written in this way by Newton's second law. We know that this is equal to m multiply mass multiply acceleration multiply displacement. Now we know another relation, that v square is equal to u square plus 2as, where u is the initial velocity, v is the finishing or last velocity, e is the acceleration, and s is the displacement. So if we take u is equal to 0, then we will get v square is equal to 2as. So here acceleration you can find out, this will be equal to v square by 2s. So from this we will get the work done to generate the kinetic energy. So W is equal to m a s. If we replace this by this term, we will get m v square by 2s multiply s. So this is equal to, s is vanishes, this will be half m v square. So any object which has a velocity v, which performs work equal to w, then its kinetic energy will be half m v square. So this work totally transforms its kinetic energy in form of kinetic energy. So this is the numerical form of the kinetic energy. It is equal to half m v square. Now, the numerical form of potential energy is it will draw a particle. This is the Earth's surface. It will take a mass m, which is moved upward and stored in a height, this object at height h. this is the height h. Then we have to find out the potential energy stored in uh, this height. So in this object at this height. So here the work done is against of the weight of this object. So its weight is equal to mg, and by the definition of weight, this is a force which we need to overcome to reach this height. So here the force, the work we have to do to perform to attain this object at this height is equal to force multiply displacement, which is equal to h. So your force is mg and height is h. So this work is stored as a potential energy in this object at a height h. So this is a numerical form of the potential energy. We have to remember this. Thanks for watching.